Hey everyone, welcome back to our channel. If you're new here, make sure to like, share, and subscribe so you never miss an important lesson. Today, we're going to break down an essential chapter in chemistry, structure of the atom from class 9 cert science. The idea that matter is composed of tiny, indivisible particles dates back to ancient Greece and India. Greek philosopher Democritus suggested that all matter is made of indivisible particles called atoms. He believed atoms were indestructible and different in size and shape. Indian philosopher Maharishi Kaneda proposed a similar idea, naming the smallest unit of matter Parmana. Both theories lacked experimental proof until the 19th century. John Dalton, an English scientist, formulated the first scientific atomic theory. All matter is composed of indivisible atoms. Atoms of the same element are identical. Atoms of different elements have different properties. Atoms combine in fixed whole number ratios to form compounds. Chemical reactions involve rearrangement of atoms, but atoms themselves cannot be created or destroyed. Later discoveries showed that atoms are not indivisible. They are made up of subatomic particles. J. Thomson's discovery of electrons in 1897 came from the cathode ray experiment, where cathode rays were negatively charged particles known as electrons. Goldstein's discovery of protons in 1886 was through the anode ray experiment, where positively charged particles were discovered, known as protons. James Chadwick's discovery of neutrons in 1932 came from the beryllium bombardment experiment, where neutral particles inside atoms were found, known as neutrons. Thomson's plum pudding model in 1897 depicted the atom as a positively charged sphere with embedded electrons, but it couldn't explain atomic stability. Rutherford's nuclear model in 1911, based on the gold foil experiment, showed that most particles pass through, indicating that the atom is mostly empty space, while some deflected, revealing a small, dense, positively charged nucleus with electrons revolving around it. Bohr's model in 1913 proposed that electrons revolve in fixed orbits with specific energy levels and do not lose energy in these orbits. Subatomic particles, protons, and neutrons form a nucleus, while electrons move in shells around the nucleus. According to the Bohr and Berry rules, the K shell can hold 2 electrons, the L shell can hold 8 electrons, and the M shell can hold 18 electrons. The outermost shell cannot have more than 8 electrons, except for hydrogen and helium. The atomic number, Z, is the number of protons, and the mass number, He, is the sum of protons and neutrons. For example, carbon has an atomic number of 6 and a mass number of 12, while oxygen has an atomic number of 8 and a mass number of 16. Valency, or the combining capacity of atoms, is determined by the outermost electrons. For example, oxygen has 6 outer electrons, so its valency is 8 minus 6 is equal to 2, while sodium has 1 outer electron, giving it a valency of 1. Isotopes are atoms of the same element with different mass numbers, while isobars are atoms of different elements with the same mass number. Applications of atomic structure include medicine, such as isotopes like cobalt-60 in cancer treatment, industry, like uranium, 235 in nuclear power, and electronics, where semiconductors work due to atomic structure. Atoms are the fundamental building blocks of matter. Understanding atomic models helps explain how elements react and form compounds. That's all for today. Like, share, and subscribe for more lessons. See you in the next video.